Hi, I'm Stephen and welcome to Audio Nautica, and I'm moving along with my assembly of my Pearl 3 Phono amp from DIYAudio Shop, and I'm moving on with the power supply construction. If you haven't seen my earlier videos, make sure you do look at those to see how the preamp stage was built. And in this video I'm going to build the power supply. Now, just a very important caveat, the power supply has mains voltages inside of it, so if you are not competent to work with mains voltages, do not. Furthermore, you need to be certain that it is legal for you to do so in your jurisdiction. It may not necessarily be legal in all jurisdictions to work on mains voltages. So I'm just following along the procedure as I have been, and beginning with assembly of the circuit board itself. I'm going to follow the same procedure as I did on the preamp board itself, and that's begin with the lowest components in height. There's not that many components on this board. So I've already inserted all of the resistors. I haven't soldered them yet, so I'm about to do that. But I've fitted all of the resistors. The other thing that I have fitted is this link here is necessary to select your mains input. If you forget this link, it will not work because your transformer will be open circuit to the mains. But it's very, very important to get this correct. It needs to be strapped either for 120 volts or for 240 volts. Just want to note too that this board was designed by Randy Thatcher. He actually sent me this board, so thank you Randy for sending this board to me. This is a new design of the board which will allow me to fit the particular transformer that I have, because not all of the transformers are as available as we'd like them to be, shall we say. So Randy's redone the board so that there's more boards will physically fit. This is so it will fit inside the 1U chassis. If you don't have the 1U chassis problem, then you can just use a toroidal transformer. There's a mounting hole here, and I've got one, but it's too tall to fit inside the chassis, so that's why I'm using this board. The other thing that I've done also is the snubber resistors are optional. If you leave them out, then the snubbing won't work, obviously. But what you do is you use the Quasimodo test jig. This is the one that I built. Make sure you check the first video in my playlist. That will tell you all about this. So I calculated that 33 ohms is the value that I need for my setup. I've fitted the 33 ohm resistors, but you can't guess. You actually need to experimentally calculate it, and that's what this test jig is for, to do that. So I'm going to solder these resistors in and I'll press on from there. Okay, just a bit of an update for you guys. So I have got those resistors installed, and I've also fitted some of the other low components, such as these capacitors, the safety capacitor here, this little connector, JST XH series, again, that I'm going to use to connect the LED, just as I did for the preamp stage. There is an allowance for a couple of other LEDs for each rail, the positive side and the negative side. I'm not going to bother installing those. I'm not particularly interested in those. I just want the one that'll be seen from outside. So this is the mains in. I can actually see, looking at it straight down, that the connector's a little bit crooked, so I might just try to fix that. And I have not fitted the connector here because I'm just going to hardwire onto those pads. They've got holes in them like this, which makes them a little bit difficult to fill up with solder. Yeah, you can see how yucky that one is. I might have to take some of that solder away because they've got these gigantic holes there. The solder just keeps feeding in. Basically what I want to do is to use them as surface mount pads effectively, and I'm just going to solder the 3 wires. This is to the umbilical cable, and I've already made my umbilical cable up, and I know that those wires are quite light gauge so they'll work best just being soldered straight on there. So I'll need to resolve that. But anyway, I'm just going to press on and install the rest of the tool components and then come back to you. Okay, so that is now everything fitted except for the power transformer. And if you saw my earlier video on the phono stage, what I did is I used some liquid flux, this stuff here, and I reflowed all of the joints, and I did that as I went. This time I didn't do that because I decided I'm going to do it now at the end. It was a bit tricky keeping track of just which ones I'd done and which ones I hadn't, so now I know I've got to do them all. It's not necessary. This should work perfectly fine as long as all of the joints don't have any problems. But it will just make the job look a whole lot nicer. And you can see how there is flux on the bottom of the board. Again, it's not a problem, but for something that looks as professional as possible, I like to take all of this off. As I said earlier, in the factory, we certainly would have done this. We had a washing machine, automatic washing machine that would take all the flux off. So I'm going to reflow all these joints to make them as nice as possible, and then I will clean it. And have a look at the difference after it has been cleaned. Component side, there's the solder side, and all the flux is gone, and I've reflowed all of the joints, and that's looking pretty darn close to factory if I do say so myself. So that's what we're trying to achieve. So I decided to leave the transformer off just to make it a bit easier to clean, so I'll fit that now and do a local clean, then we're ready to start with the chassis. Just quickly guys, these pins on the bottom of the transformer are quite long, they're longer than anything else, and these will have mains voltage on them, so I'm just going to trim these back. I think it's better to have more clearance to the chassis. Okay, that is much better. This is now ready to go in. Okay guys, the assembly is coming along quite nicely. So I've got the standoffs mounted in the bottom panel, just exactly the same way we did them on the preamp board, Loctite it in position. Sanding back the coating here because this is our chassis reference point. So that's where chassis for the board connects. And I have got the IEC power inlet mounted on the rear panel, so you can't see it, but I ground back underneath so that there is a good electrical contact to the actual earth point, because this is the earth point here for our whole system, which is connected through to the earth point coming in from the power lead. So that is quite important. And I decided it's also important for all the chassis points to be bonded to earth, so I've kind of sanded back some points so that this is earth, this is earth, this will be earth through here, and same on the front panel. I haven't worked out how I'm going to do the top enclosure yet, but I'll do something for that as well. Just want to give you one very important tip, because whilst there is a rocker switch built into the mains inlet, it's a bit of a pain. I have to reach behind to turn it on and off. So the design has a switch on the front panel, which is how we turn it on and off. Now firstly, the switch that is on the BOM, when it turns up from DigiKey, if you're in a 240 volt country like mine, you look at the front panel, look at the packet, and you'll see 120 volts. But if you look at the data sheet, as I did, you'll see that that's just to do with the contact rating. So it's rated at 5 amps at 120 volts. It's rated at 2 amps at 240 volts. So it's not that it's not rated for 240 volts, it's just that the 5 amp contact rating is at 120. And it's rated for 2 amps at 240, so that will be perfectly fine for us. So these are the kinds of things you need to go and check that they're okay. The other thing that I want to point out that is quite important on that switch is this is common, and this is the switched contact here, all right? So what that means is in this position, which is the off position, the common contact will be connected to this terminal here. In the on position, common contact will be connected to this terminal here. Now, what we don't want to do is connect the line to the common point, because if we do that, it means that this terminal will become live in the off position. It's not a huge deal because it's not going anywhere, but it's just good practice, in my opinion, to have as few things live as possible. And I think it would be bad practice to liven that up, because you would assume that it's not connected to anything. It doesn't go anywhere, right? So you could assume, for whatever reason, I don't know why, but you could assume that there's nothing there when the unit is off and that's actually live. So that is the reason why I will be connecting the live one of these two to this point, and then when it's in the on position like this, it will switch it through to the common terminal. So I made up some more twisted wire, which I'm going to use to run it to where it needs to be. Okay guys, this power supply is just about done, so I just want to show you a few things about it. So I did make a couple of small mistakes. So one thing is the 1 watt bleed resistors. The printed procedure says to just space them up off the board. Now that's not noted in the online procedure, which is what I was following along. So I did not space them up, but to be honest, I really don't think it's going to make that much difference. So I'm not going to bother rectifying that. The other thing that's a little bit different from the online procedure too is the hole positions in this chassis have changed. So in the online procedure, the board is spaced back about here. The edge of the board is basically on this rib. And now, as you can see, it's not, which means that this is all quite close to the front panel, which makes this a bit crowded. So it, quite frankly, would be better if it was back where it was originally. I guess the idea is this gives it a little bit more heat ventilation, but I don't really think that's going to be a big deal for this thing. We're talking pretty low power. So, but anyway, that's okay. I worked around that. So then the other thing, of course, is to make sure that you check all of your work, of course, because as I said before, it's mains. And if you're really not competent with this, you shouldn't be doing it anyway. So before you connect the power, buzz everything out to make sure that you have the active going through to where you expect it to be. So this here is the active, and this here is the neutral. So the neutral is going directly to the power in module, whereas you want the line, the active, to be switched through the front panel, which it is. And I talked earlier about just a couple of things to note with the way in which that is done. So I've got my chassis earth connected here, going directly to the earth pin on the mains lead. And then this here is where our earth for our umbilical cord is going to connect. So I also made one other mistake too, only one, you say. No, it's all right, don't worry. I fitted the wrong resistor for the power on LED. So when I did the initial test, no LED, which makes you think it's not working at all, but buzzing things out pretty quickly showed that I had mains where I expected it and I had DC out where I expected it. I'll show you that in a tick. But I fitted this LED here, which is actually for this one here. So I needed to fit this resistor for this LED, which is the one that I've wired up. So it was a bit of a pain because it meant that I had to fit this LED after I'd installed everything. I didn't want to pull the board out again. So what I did is I just pre-cut the LED, pre-cut the leads to the correct length, bent it, and sat it in place, and then just soldered it from the top. And so it's not quite as neat as I'd like it to be, but that will be fine. So that's about where we're at. So let me just show you this thing working. There we go, we have the LED is on. There's the positive DC out, it's about 27 volts DC. And that's the negative volts out, negative 27 volts DC. Now that is no load, so it should come down when it's got a load on it, but I would note that in accordance with the bill of materials, I've got 25 volt rated capacitors fitted to this line. Usually I'd like to have a little bit more headroom than that. We'll see what it floats down to when it's got the load connected to it, but that's what was in the BOM 25 volt caps, so that's what I went with. But I guess it's not too surprising that it floats up a bit higher than that. Anyway, that's where we're at. So the next thing we need to do is get the umbilical cable fitted and hooked up to our preamp. Okay guys, the umbilical cable is now connected, and I have done an initial test which I'll just show you, but it's all working very nicely. I also checked the voltages here with a load. They're about 22.5 volts, so I'm happy enough with that. As I mentioned, these caps are rated at 25, so that will be fine. So just also just because I want to have the lid when it's put on well and truly connected to chassis, I've just done my little trick with the copper tape again. And there's a void on the inside of the lid that looks a lot like this. I know it's not pretty, but anyway, that will make good contact with that copper tape and just make sure that the lid is properly connected to chassis. I think that's just a good idea. So let me just show you the front now. Okay, we turn the power on, and voila, power LED, that is all working. Okay guys, this was supposed to be the outro clip, but believe it or not, we've run into another problem. And this is the reason why they call these things Pioneer kits. It is so frustrating, because basically every time they make one of these, there's like some inconsistency with the BOM, there's a part that they can't get, so they have to substitute it. This is the difference between something that is commercially produced and something that isn't. And even when they make something again that is theoretically mass produced like the chassis, it's not the same, and that causes construction problems. So I mentioned in my video on the phono part that they'd changed the chassis so that originally the lid was just a straight piece of metal, and now it has a flange. And so on the phono stage it obscures the text so that you can't read the text. On the power supply stage, the problem is even more catastrophic than that. So if you have a look, you'll see that this flange, it fouls on the power inlet. And when I put the power inlet in, I debated as to whether it was meant to go in this way or from the inside. From the inside it looks terrible because the cutout does not match this rectangle here. So, and also if you put it on from the inside, you can't easily connect this piece of metal to the chassis. So I've ground back part of the anodizing here so that this metal here is connected straight to chassis. So long story short, you can see that this lip here is fouling on here, which means that the lid does not sit down properly. Also, I found that there's little manufacturing defects in these chassis as well. I've had to bend them all here. Usually they've been bent in this way a little bit, meaning they won't fit, so I've had to attack them with the hammer to get them to fit at all. And this one, you can see that just the manufacturing tolerances also, you can see here, it does not go all the way forward. So there's a gap between the front panel and the lid, which is not really what we want. And because the lid is not sitting down, I could not use the chassis screws that came with it because these are countersunk. But with the lid sitting up like that, they're not long enough. So I had to use some of these other screws that I had. So I've now got different screws. I've got those two screws are different to these ones here. These ones fit, but these ones don't because the back of the lid is sitting up. So really, really annoying. Just those kind of things, as I say, that happen with, you know, kits and these sort of like pioneer projects. But anyway, I think I'm going to call this a wrap. It is as complete as it's going to get. At some point I will do a later revision video on the entire project. So after I've had a chance to listen to this preamplifier for quite some time in my system, I will do a review of it. So please make sure that you're subscribed to my channel with notifications so that you don't miss that video. If you've appreciated my work, you can support me over at Patreon, or you could leave me a super thanks. I'm very grateful. Please like my video if you enjoyed it, and I really love to read your comments down below. Thanks so much for coming along with me on this journey for this Pearl 3 Phono Preamp from DIYAudio Shop, and I look forward to seeing you on the next video. Bye for now.